The search for water in space is a fundamental quest in astronomy and planetary science, driven by the search for life beyond Earth and the pursuit of understanding our cosmic origins. Water is essential for life as we know it, and its presence in space is a key indicator of potentially habitable environments. Observations of our solar system have revealed that water is more common than once thought. The most significant discovery is that of water ice on the Moon. Initially, the Moon was believed to be completely dry, but recent missions have detected ice in permanently shadowed craters at the lunar poles. This discovery has implications for future lunar exploration, potentially providing a resource for human missions. Mars has been a primary target in the search for water in space. Evidence from orbiters, rovers, and landers indicates that Mars once had liquid water on its surface. Features such as river valleys, lake beds, and mineral deposits suggest that water was abundant billions of years ago. Current missions are focused on determining whether Mars could have supported microbial life and whether it still holds water in the form of underground ice or briny subsurface flows. The icy moons of the outer solar system are particularly intriguing in the search for water. Europa, a moon of Jupiter, is believed to have a subsurface ocean beneath its icy crust, kept liquid by tidal heating from Jupiter's gravitational pull. Similarly, Saturn's moon Enceladus exhibits geysers that eject water vapor and ice particles from beneath its surface, suggesting an internal ocean. These moons are prime candidates in the search for extraterrestrial life, as their oceans could provide the conditions necessary for life to develop. Comets and asteroids are also key sources of water in space. Comets, often described as dirty snowballs, are composed of ice, dust, and rocky material. They are thought to have delivered a significant portion of Earth's water when they collided with our planet in its early history. Studying comets, therefore, provides insights into the early solar system and the origin of water on Earth. Asteroids, particularly carbonaceous asteroids, are also known to contain water, further suggesting that water is widespread in our solar system. Beyond our solar system, the search for water extends to exoplanets. Astronomers use space telescopes to analyze the atmospheres of distant planets, searching for signs of water vapor. The presence of water vapor in an exoplanet's atmosphere is a tantalizing hint that the planet could have conditions suitable for life. Recent discoveries of Earth-like planets in the habitable zones of their stars have raised the possibility of finding planets with liquid water on their surfaces. The search for water in space also has significant implications for the future of human space exploration. Establishing the presence of water on other celestial bodies could pave the way for human colonization. Water can be used for drinking, growing food, and producing oxygen. Moreover, water can be split into hydrogen and oxygen, providing fuel for rockets, making it a vital resource for sustaining long-term human presence in space. Technologically, searching for water in space requires sophisticated instruments and missions. Orbiters and rovers are equipped with spectrometers and other sensors to detect water and ice. Telescopes, both ground-based and in space, are used to observe water in the atmospheres of planets and moons. Future missions are planned to directly sample the water from moons and asteroids, providing direct evidence of its composition and history. In the broader scientific context, understanding the distribution and history of water in space helps to answer fundamental questions about the formation and evolution of planetary systems. It sheds light on the processes that led to the formation of Earth and the emergence of life. The search for water is not just a search for a molecule, it is a quest to understand our place in the universe. One of the most promising technologies in the search for water is spectroscopy, a technique used to analyze the light spectrum emitted or absorbed by objects in space. This method can detect water and other molecules, even at vast distances. Instruments aboard spacecraft like the Hubble Space Telescope and the recently launched James Webb Space Telescope are equipped to perform such analyses, offering insights into the composition of distant planets and moons. Future missions to Mars, including manned missions, are being planned with the objective of further exploring the planet's water history. The Mars 2020 rover, Perseverance, is equipped with instruments capable of detecting and analyzing subsurface water and ice. Its mission includes collecting samples that could be returned to Earth for more detailed analysis, potentially answering whether Mars ever harbored life. The exploration of Jupiter's moon Europa is another exciting frontier. NASA's Europa Clipper mission, slated for launch in the 2020s, aims to closely study Europa's ice shell and subsurface ocean. It will assess the Moon's habitability and pave the way for future missions that might land on the Moon's surface or even probe its ocean. Additionally, Saturn's moon Titan is another target in the search for water and life. While Titan's lakes and rivers are composed of hydrocarbons rather than water, its subsurface may harbor water ammonia oceans. The upcoming Dragonfly mission aims to send a drone-like lander to explore Titan's complex chemistry and potential for life. The search for water in space isn't just limited to our solar system. With the advent of advanced space telescopes, astronomers can detect signs of water on exoplanets, many light years away. These discoveries are vital in identifying potentially habitable planets. The study of these distant worlds not only informs us about the potential for life elsewhere but also helps us understand the rarity and preciousness of Earth's water-rich environment. Space agencies and researchers are also increasingly focusing on asteroids as potential water sources. Missions like NASA's OSIRIS-REx and Japan's Hayabusa 2 aim to return samples from asteroids to Earth. Studying these samples could provide clues about the early solar system and the role asteroids played in delivering water to Earth. In addition to scientific exploration, the search for water in space has practical implications for future space travel. In situ resource utilization, ISRU, is a concept focusing on the extraction and use of local resources, like water, to support space missions. This approach could be crucial for future lunar bases or missions to Mars, reducing the need to transport water and other resources from Earth. The search for water in space also raises philosophical and ethical questions. As we discover more about water's prevalence and role in the universe, we must consider our responsibilities in utilizing these resources, especially as we plan for potential human colonization of other worlds. The search for water in space is a journey that connects us to the most fundamental questions about our existence and place in the universe. It's a quest that spans the cold vacuum of space to the inner workings of distant worlds. As our knowledge expands, so too does our understanding of life's potential beyond Earth. The future of this search promises not only scientific breakthroughs but also a deeper appreciation of the cosmic tapestry in which Earth is a single, blue, water-rich thread.